The question we're working on here is question 5 from the sample questions that are put out by NESA for the new HSC physics syllabus. So we've got a 15-gram ball. It's swinging around on a circular trajectory with a radius of 0.8 meters, and it's moving with an angular velocity of 4 pi radians per second. And we've got to work out what's the centripetal force that's required to maintain that constant motion. First up, we want to make sure we understand what we mean by 4 pi radians per second. So we say, basically, if we start here and we go all the way around, we get to there, that's pi radians. So that's half a circle, that's pi radians. And if we go the rest of the way around, we've gone 2 pi radians. So when we do 4 pi radians, that means we've gone all the way around and all the way around again. And because it's 4 pi radians a second, that is 2 laps of that circle per second. So that's kind of the first and most fundamental thing that we need to understand in order to be able to work this out, is that it's done 2 laps. So let's start unpacking that. First thing we need to do is we're going to need to work out the circumference, and of course we do that with pi d, and d is going to be the diameter of the circle. We've been given the radius here, and the diameter is obviously 2 times the radius, so we're going to say pi times 2 times the radius, which was 0.8, and that's going to give us a circumference of 1.6 pi. So 2 times 8, lots of pi. So that is our circumference in meters. Okay, we've now got that. Next thing we're going to need to work out is velocity. So we've got our circumference. Our velocity is going to, I don't know what that was about. Our velocity is going to mean that we need our distance over time. So velocity equals distance over time. I think my pen battery is running low. I think that's what those weird spikes are about. So we've got distance, and the distance is going to be that circumference, 1.6 pi, that circumference times 2. Because we've got the ball bearing doing 2 full laps of that circle every second. So 1.6 pi times 2 every 1 second. The alternative way of doing that would be to say it does that full lap in half a second and put a 0.5 on the bottom instead of a 2 on the top, but that's going to achieve the same thing. So we now have a velocity of 3.2 pi meters per second. Okay, so we've got those 2 values. I suppose we can do away with our circumference. Now, the value we really need to remember is this one. We've got 3.2 pi meters a second as our velocity. Have a quick look at our equation sheet. If we have a look on there, we should be able to identify which formula for us. It's the centripetal force equation, F sub c equals mv squared on r. Question, we'll write that down now. We'll say Fc equals mv squared on r. And remember, we just wrote down v. We just said v was 3.2 pi meters per second. Okay, so all we've got to do now is plug those values in. We've got F sub c, we'll put our mass in as 0.015 because it's going to be in kilograms, times that velocity, 3.2 pi, and we'll square that because it's v squared, and we'll divide it by our radius, which is 0.8. Okay, once we put that in and hit equals, we should get an answer that's roughly 1.9 newtons. It may actually come up as 1.89 or something like that. I can't remember. I worked it out earlier, but it should give us an answer for centripetal force that is roughly equal to that, which of course gives us B in the multiple choice. Hopefully that's been helpful.